So we want to look at number of atoms, number of molecules, and number of ions. How do we calculate that? So we've met Avogadro's number today. So 1 mole of an atom or 1 mole of a substance contains 6.02 times 10 to the power of 23 number of that atoms or number of that particles of that number of atoms or number of molecules or number of ion. So the number of atom or molecule or ion in n mole of a substance, because we said if it is 1 mole of any substance, we said it contains 6.022 times 10 to the power of 23 atoms, for example. So if it is now n mole, unknown number of mole, so what will it contain? So if I change this question mark, I change it to X. So I want to show you how we got this formula down there. So let's change this to X. And remember, this 6.022 times 10 to the power of 23 is Avogadro's number, which is N of A. So this is 1 mole. Now, we want to calculate number of atom. So we make X the subject of formula. X will equal to number of mole times Avogadro's number. So our X, we can change it to N if I use capital letter N instead of X, and then we get that formula. So let me just replace this one with N, which is number of atoms. So that is how we got this formula down here. And remember, if we want to calculate mole, you know that number of mole equals mass over molar mass. So you get everything, you have everything you need to calculate number of atoms or number of molecules or number of ions in a substance. So let's go ahead and use this in calculation. So we have this question. We are asked to calculate the number of zinc atoms in 1 gram of zinc. So we have the mass and then we have the molar mass of zinc. So just now we said number of atoms equal number of mole times Avogadro's number. So number of atom equals number of mole times Avogadro's number. So, but this question we don't have number of moles. But remember we said number of mole equals mass over molar mass. So the mass is 1 gram and the molar mass is 65.38. So we can plug that in to calculate number of atoms. Now N equals 1 divided by 65.38 times 6.022 times 10 to the power of 23. So anything you get from that will give you the number of atom in 1 gram of zinc, and that is 1.529 times 10 to the power of minus 2. Is that? No, that is molar mass. Yeah, this is number of mole actually. So this number of mole, that is 1 divided by 65.38 will give you 1.59 times 10 to the power of minus 2. So let's make this one smaller. So let's go ahead and now multiply it by 6.02 times 10 to the power of 23. That is times 6.022 times 10 to the power of 23. Our final answer will be 9.207 times 10 to the power of 21 atoms. So if you count the atoms of zinc in 1 gram of zinc, that is what you are going to get. You will get 9.02 times 10 to the power of 21. That is a lot. So let's go ahead and look at this another calculation here. we are asked to calculate the number of molecules of calcium carbonate in 14 grams of calcium carbonate. As we know, it is still N times number of mole equals number of mole times Avogadro's number. Number of mole equals mass over molar mass, and the mass is 14 grams, and the molar mass of calcium carbonate is 100. So 14 grams, 100 grams per mole. So this one will give us mole, which is going to be 0.14 mole. So we have the number of mole, and we know that N equals, so N now will equal to 0.14 times 6.022 times 10 to the power of 23. So that will give us the final answer, which will be 8.43 times 10 to the power of 22. Is it atoms? No, it's going to be molecules. We call it molecule. Actually, it's not molecule because it's not a molecular compound. So I would just call it particles. Particles. Sometimes they can call it molecules. It's not a problem, but we don't see it as molecule because it is not a molecular compound.